Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So in this video, in previous video we had seen about the military application of the fibers of different types, that carbon fiber, glass fiber, that glass reinforced fiber. Now in this video we will see about the Aramid fiber reinforced plastic. Now AFRP, there it was what? Carbon fiber and glass fiber, CFRP and GFRP. Now here we will see AFRP and the hybrid composites. Okay, so our lecture topic will be what? Aramid fiber reinforced plastic and hybrid composite. So let's see first Aramid fiber plastic and that. So in modern air structure, or that you can see that aircraft structures, there is often used Aramid fiber reinforced plastic, AFRP, for example Kevlar. So that AFRP is Kevlar, not where it is used, right? So nowadays in a structure, often they are using the Aramid fiber reinforced plastic or AFRP. That what Kevlar is one of the type of Aramid fiber reinforced plastic. That Kevlar already I discussed in the class lecture itself. So you can just go to the module 3. There you can find the details about the Kevlar. It is one of the strongest synthetic fiber ever created. So what is Kevlar? One of the strongest synthetic fiber. Synthetic means man-made, right? So one of the strongest synthetic fiber ever created. So whatever the synthetic fibers are there in that all, who is that? That Kevlar is the strongest one. A common features of the family of these products is high tensile strength with low specific weight. What is the main feature of this one? Is what? Having high tensile strength means at higher load they can sustain with low specific weight. Means at low, that also in just another word you can say weight to strength ratio is very high in case of Kevlar. Okay, or Aramid fiber reinforced plastic. At the same weight, it is 5 times stronger than steel. So just take same weight, 100 gram of steel and 100 gram of Kevlar or Aramid fiber reinforced plastic. That will be 5 times stronger than the steel. So now what happened? Now so instead of 100 gram steel, 20 gram only the Kevlar is required to get the same strength. So means weight got reduced by 1/5 of that one. So only just 20% weight is there, 80% we can eliminate. The material is outstanding for its excellent thermal strength, dimensional stability and low elongation at break. So what is that? They are very good in thermal strength. With the change in temperature, they are not getting affected, right? Dimensional stability also is there and low elongation at break. If suppose some part got break or having some fracture, then what happened? Elongation, this propagation of the crack will be very slow. It is anti-corrosion and resistance to most chemicals. So it's anti-corrosion means what? It will not get corrode, and resistant to most chemical means it will not react with the chemical. Also most of the chemical it will not react means what? That chemical property is also stable. Kevlar fibers are uni-inflammable, non-conducting wear resistance. So means even that wear resistance also is that it cannot wear, that what wear, and uninflammable. This cannot burn also means here fire cannot catch. With this unique combination, so just unique combination is what? They are 5 times stronger. Strength to weight ratio is very high, right? Propagation, elongation of at break means the propagation of the crack also is very slow. Then thermal strength is also too high and dimensional stability. So because of this property, right? So in what happened? So because of this property, what happened? With this unique combination of properties, whatever I will discuss of this material, it is used in many aviation construction. So in aviation construction, whatever is there, because of these above mentioned property, that this just like strength to weight 5 times stronger, dimensional stability, chemical stability, because of this they are using in many aviation construction. In the design of aircraft, large module of Kevlar fiber in conjunction with its high impact resistance allow designer to reduce the weight of many structural element and to improve the mass load characteristics. Means what? Because of after the Kevlar, just when they are combining with the Kevlar, what happened? Their mass can, the designer can reduce what? So who is designing or just that means weight can be reduced for the structural element and hence mass to load characteristics got increase. From Kevlar, rotor blades, main and tail were made. So with a rotor, because that is the most rotating part of the engine, right? So that should be the very, very strong. So from Kevlar, rotor blades, main and tail were made. And its interesting solution is so-called Kevlar bath. That is the what? That as Kevlar bath. Now in Kevlar bath, what happens is inside Kevlar bath, the seats are embedded where the crew is located. Its task is to protect against artillery shells up to 23 mm. You can see in another word, what? That has bulletproof type. So up to 23 mm, they can, that artillery shell, they cannot allow to penetrate up to 23 mm that is there. So that can be used as a bulletproof, also bulletproof the glass. Massive use of Kevlar in the construction of aircraft is rather negligible due to high price, and it's not like that they have that much property so we can use everywhere Kevlar. Why? Because they have very higher price. So very higher price and we will implement everywhere the Kevlar, then just imagine how much price of that aircraft will be there. So everywhere we cannot implement also. So where we can, where we can see that frequently that can damage or more wear and tear or these things are there we can go for the Kevlar. Mainly it is used as a material to reinforce element of the heavily thermally and mechanically loaded. So where it's a heavily thermally and chemically, means where the chemical and thermal reactions are possible or by the changing, like just in engine, what happens, the temperature goes up to more than 2000 degrees Celsius, right? So if other things can be used, then what happens, the chances are there that will lose their property. So there we can use the Kevlar. So that already is here, that in rotor blades we are using. Right. For that part, even we have to spend much, then also we cannot, they are doing. In recent year, a lot of interest is given to fiber metal laminates, that is FML, fiber metal laminate. So fiber and metal, just combine fiber and metal to form a laminates, that is called fiber metal laminates. These are material made of thin layer of metal sheet and fiber. So these are just combination of metal sheet and fiber. An example of the application of composite material type of Kevlar is the American helicopter Boeing AH-64 Apache. So in Apache, that is very costly and having many features, right? So AH-64 Apache, they used Kevlar. Where? Okay. So the first study done on the wing of the aircraft S-11 and F-27 confirmed their increased mechanical property, which have helped to conduct further research. Means what? The first, in starting, they used the Kevlar and then they found what? In aircraft S-11 and F-27, that with that, after using, they confirmed that what happened? Their mechanical property got increased. So once mechanical property got increased, then why that got increased? Then they checked, okay, here the composites got used. So after that, they started researching, right? They found, okay, why that got increased, how much that got increased. So further, they started researching on that one, and finally they conclude, okay, they have just all the property like 5 times more strength and there is no chemical reaction and all. So because of that only, there what that got increased, the property got increased of that one. As a result of the application of strengthened glue that connects the metal and fiber, the effect of cracks propagation was 3 times slower. So what glue is used to combine the metal and fiber, that are because of the strength of that glue, what happened? The propagation will reduce 3 times, or you can say 3 times it becomes slower. The result of this points to the significant benefit that give possibility to use FML to the aircraft construction. So because of that only, the fiber metal, okay, laminates will use. Why? Because in case of fiber metal laminates, that crack propagates 3 times slower than the other. Besides, delamination connected with crack significantly decrease the propagation speeds. Besides lamination, so lamination will be there, but crack significantly, the propagation of crack significantly decreased. That is speed of the propagation. On the basis of this knowledge and subsequent research, there was created GLARE, G-L-A-R-E, that is glass reinforced, okay, the glass reinforced or glass reinforced aluminium laminates. Composite, okay, this is another type. It consists of 2 to 6 layers of aluminium thickness of 0.2 to 0.3 mm. So in that layer, what is there? Here 2 to 6, depending upon the requirement, 2 to 6 layer of aluminium thickness. Between the layer of aluminium, there are alternately layers of fiber and metals is used. So means what? Here aluminium, then here fiber is there. Then another metal, fiber, aluminium, metal, fiber, like that. So number of layers can be formed. So up to 6 we can use the layer of aluminium. S-glass fiber oriented of a thickness of 0.25 to 0.5 mm. So S-glass fiber, that is type of the glass fiber, right? They have the thickness of from 0.2 to 0.5 mm, are connected by matrix of epoxy resin. So now that glass fiber combined with matrix, that is of what? Epoxy resin, and combined with aluminium. So now let's see here 3. Okay, that got combined. In view of its specific property of the glare becomes the subject of research in the context of military aviation. So whatever their specific properties there that got increased or changed, now they are, or we can say that can be used in the military application also. During the bullet hole caliber 16.5 mm. So just say during the bullet hole caliber, penetrating an obstacle with composite glare with the speed of 171 meter per second, there was observed only local destruction at the site of impact of the projectile and its area. Means what happened? Once that of 16.5 mm caliber bullet with a speed of 171 meter per second, just almost you can say half of the speed of sound. With that speed also, if it's moving, then it's what happened even after hitting that glass, just local destruction is there. It cannot penetrate the whole thing, and that can be kill the person or anything. So means that is just like a bullet proof. Okay. Aramid fiber. Okay. No occurrence of brittle crack. In this case, what happened? Brittle crack is not occurring. Very dangerous in aviation structure were noted. Right. This is also. Besides test for concentrated dynamic load, finishes successfully demonstration caused by point load were plastic and visible visually. So what happened? That is how that is not, that cannot be used because layer by layer is there. So once that particular layer will be there, in that layer growth will be there. The overall propagation will reduce by 3 times, but that in layer wise that will be there. Glare material is characterized by low weight, high corrosion and fire resistance. Okay, so they have the lower weight, higher corrosion, and it's a fire resistance. Means if where the glare is used, their chances are very less to catch the fire or fire will be there. Despite these and many other advantages of these materials have certain restrictions that limits their uses for aviation. So though they have the properties, again they will have some drawback also. What is that? A significant impact on their use have adhesive glue connection. So once they are using that, already we are seen by using the glue, they are reducing the 3 times. But what happened that glue? Okay, applied between its layer, right? So that have the glue also that is used. If glue is not as strong, then it cannot sustain that layer itself, that will get damaged. During using the connection in the glare, composite can be adhesively and cohesively destroyed. Adhesive means along the surface itself it will get broke and cohesively also. So means either layer by layer, once suppose one layer over the other is a stick. So now this will get separated adhesively, right? And if cohesively means this will break, but at the same time the other layer also will get break. The maximum cohesively strength between thin layer is about 100 megapascal. Adhesive strength and typically lower, and it indeed depends on the preparation of combined surface for bonding. So that is required. That's why just now combined surface of the bonding is required. If this bond is there, how it's breaking? If cohesive is there, right, then it's okay. Then they both will break simultaneously. But if adhesive is there, the another first layer will break, then another layer will break, like that. Even if there is applied an effective preparation of the surface for gluing, for example, in the pickling form or anodizing of aluminium alloy, allowing high adhesive strength of the connection, local stresses in the adhesion layer order of 100 megapascal. So with that, if suppose the aluminium alloy anodizing of that one, that in that case what happened? The local layer of the what happened? The local stresses will be of the order of 100 megapascal. Okay, so destroy it. So 100 megapascal stress will destroy. Also this one cause delamination of laminar composites. So once 100 megapascal load will apply in the adhesion layer, that will get damaged or that will get destroyed, and hence that will cause as the separation of lamina, or you can say delamination of laminar composites. Okay. Now next is metal matrix composite material in military aviation. So now metal matrix. In modern aerostructure, increased uses of metal matrix composite, that is MMC, metal and matrix, is observed. Matrix of MMC composites were made from iron and its alloy. Now iron is there one layer and the other one is alloy of that one. Either iron alloy, nickel alloy or non-ferrous metal. So now this type metal and their alloy can be used. That's why it's a metal matrix. Okay. And alloy mainly aluminium, magnesium, copper, silver, tin, lead, titanium, intermetal like nickel, aluminium, Ni3Al, right? Ti3Al, TiAl, intermetals means they are already inside. First they combine and there, and super alloys that can be used. MMC used in construction of military aircraft should take into account the requirement to reduce density, which basically means using matrix of only light metal. In military aircraft, what is that? To reduce the density, and hence what happens, having the lesser weight there that or lighter, that metal can be used, just like aluminium, magnesium, titanium and beryllium. So these are of lighter weights that can be used. MMC composites from other types of composites can be distinguished by mechanism of strengthening. So MMC and the other, if you will compare, then we can distinguish which one is MMC and the others because of their mechanism, how they are strengthening. In the case of dispersion, reinforcement occur at the microscopic level, atomic or molecular. In that case, what happened? And is intended by the dispersed particle motion of dislocation of the matrix. So at the atomic level, we can see there also, because of dispersion reinforcement at the microscopic level or atomic level, that also can get dislocate. Okay, or that you can see that got separated. External load is transferred in the vast majority of the matrix. So reinforcement dispersion does not improve significantly the characteristics and strength of composite in elevated temperature. So at a higher temperature, what happened? Because of the majority of the matrix, the reinforcement dispersion does not improve. Okay, significantly the characteristics and strength composite is elevated temperature. So at elevated temperature, this won't work. The impact of the reinforcement, on the other hand, is pronounced at high temperature up to 80% of the melting temperature. So the impact of reinforcement, up to that it will be there. If suppose at 100 degrees Celsius temperature it will melt, so up to 80 degrees Celsius that will perform better. Okay. Even a small participation of the particles dispersion significantly improves, for example, fatigue resistance compared with matrix or material. This is important specifically in working under a heavy load at high temperature, such as aircraft engine blades. So at heavy load, working is what? And at higher temperature, engine temperature is more than 2000. In that case, that is there. MMC composite based on the alloy like TiAl6V4. Okay. And continuous fiber made of silicon carbide. This material has been used in turbine aircraft engine. So in that what? Titanium TiAl6V4 and continuous fiber can be used in the turbine engine, the turbine of the aircraft engine. MMC composite of what? Boron and aluminium, BAL, is used in many military aviation projects. In this role, the matrix is aluminium alloy and the reinforcement are particles of boron. So in case of BAL, what is that? B is matrix is aluminium and reinforcement is boron. The advantage of this solution is high temperature resistance. So this can resist up to higher temperature compared to the other. So that is the advantage. It allows safe operation up to 51 degree Celsius, where the average composites can withstand just 90 degree Celsius. Okay, this type of laminates, 510 degrees Celsius and 190. This type of laminates were used on leading edge of main and tail rotor blades of helicopter. So this laminates can be used as the leading or trailing edge of the rotor blade of the helicopter. The example of where that is used is Sikorsky S76D, Sikorsky S92 or Sikorsky S70 and others. Okay, so these are the references. Again, there you can find the details about, even more details if you want, you can just find this is here. Okay, so wherever it's a map, that means it's a cited, you can just refer that particle full thing, just it's a given. So if you will copy this whole thing and you can paste the full paper, you will get, and there you can find more details about that one. Okay, so if you have any doubts or any question regarding that, you can just comment on the video, or you can just contact me regarding your doubts. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.